Okay, so good evening everyone. This was actually supposed to be the last session for this course, like last live session, but I'm going to take one extra session to compensate the backlog. So tomorrow from 6 to 8 we will have one more session. For those of you who are joining for the first time, like we were like running 1 week late in the schedule, so we'll cover the last week topics tomorrow from 6 to 8. So please join. Tomorrow's will be the last session. So let us see what we have seen so far. In the last class, we looked into chi-square test, and we had seen two tests, like chi-square test for independence and chi-square goodness of fit test. And then sorry, and then we moved on to cluster analysis. uh, we saw like the motivation behind clustering, like why do we need to cluster. And then okay, let me just start the presentation. Yeah, so then we looked into distance metrics, like different distance metrics, including Manhattan distance, Euclidean, and Minkowski. uh, I want to clarify one thing. Like in the last session, I think I kind of messed up a bit, like while explaining this concepts of distance. So let me just clarify it just like now. So given 2 points in space, it can be any space from 1D, sorry, one dimensional space, two dimensional space, three dimensional space, or any n dimensional space. So you have been given 2 points. Let's say, let us consider the example of two dimensional space. These are the 2 points, x1 y1 and x2 y2. Okay, so what does Manhattan distance do? It tries to find this particular distance. So if you move on only in this Cartesian coordinate system, if you just move to the right or top, means you can only move in the four direction: east, west, north, south. Okay, so in this case we are restricted to move eastwards and northwards. Okay, so the distance between any 2 points will be the distance that you are seeing over here in the dark green shade. So how do we compute this? So it is computed as x1 minus x2. It can be other way around as well. It is modulus plus y1 minus y2. Sorry. So what it is doing exactly over here? So this point, if you drop this point over here, this is x1, x2, y1, y2. So x1 minus x2 or x2 minus x1, the modulus or the absolute value of it is this particular distance, and y1 minus y2 is this particular distance. So you can see that this red one and this dark green over here and this one are the same, and that's how Manhattan distance is found between any 2 points. Now this was an example in two dimensional space. It can be extended to any dimensional space. uh, sorry. So let us see three dimensional space. You have 2 points x1 y1 z1 and x2 y2 z2. So Manhattan distance in this case will be x1 minus x2 plus y1 minus y2 plus z1 minus z2. The same logic that we saw over here, like you are taking the x distance, y distance, and in that case you are also having a z distance, like the difference in the z values. Now this was Manhattan distance. Now what about Euclidean distance? So Euclidean distance gives you the shortest path between any two points in any dimensional space. So if I have these 2 points, Euclidean distance will be the shortest path between the 2 points. And how do we compute that? So consider the right angle triangle over here. So we know the length of hypotenuse. So this is, let's say, x1, x2, sorry, x1, y1, x2, y2. So this particular point is x1, this is x2, this is y1 and y2. So this length will be x1 minus x2 modulus, and this is y1 minus y2 modulus or absolute value. So if you know the lengths of the sides of the right angle triangle, you can clearly compute this by taking, so let's say this is A, this is B, so this will be A square plus B square. Okay, so if we see, it will be x1 minus x2 whole square plus y1 minus y2 whole square and square root, and this can also be written as x1 minus x2 square plus y1 minus y2 square raised to 1 by 2. Right? Now extending this to 3-dimensional space, we have 2 data points x1, y1, z1, x2, y2 and z2. So Euclidean distance will be the direct line between these 2 points, and similarly extending this formula over here in the 3-dimensional space, it will be x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square raised to 1 by 2. Okay, and it can be extended to any dimensional space. Let's say like you have x1, y1, z1 and let's say p1 and x2, y2, z2, p2. So in general, the distance between these 2 points, Manhattan or Euclidean, can be represented as x1 minus x2 to the power p. Let us not take p over here. I think p was used for the power term in the slides. So let me take it as a1 and a2. y1 minus y2 raised to p plus z1 minus z2 raised to p plus a1 minus a2 raised to p and whole raised to 1 by p. Now for Manhattan distance, you will replace p with 1. For Euclidean distance, you will replace p with 2. And in general, this particular formula is known as like this distance formula is known as Minkowski distance. Okay, so this was 4-dimensional space. It can be any dimensional space, like you can have x1, y1, z1, a1. I don't have many variable, but you can just use maybe x11, x12, x13, and here you can use y11, y12, y13 and so on, and you can find the absolute differences between all these variables and then compute the powers and take a proper exponent over there depending on the value of p. So it can be for Manhattan p equal to 1, for Euclidean p equal to 2 and so on. Okay, I hope this concept is clear. Last time I was not able to explain this in detail owing to lack of time, but yeah, I hope this is clear now. If you have any queries, please let me know. Please feel free to ask. We'll see this in Python also now. So let me share my screen again. So in this week we are going to study cluster analysis. We'll continue from where we left last time. We saw some basics of like basic motivation to do clustering, and we'll see like different types of clustering in this week. One of them is k-means clustering. I will touch upon hierarchical clustering, and I'll continue with this in tomorrow's session. So for those of you who are joining now, I'm going to take one extra session tomorrow from 6 to 8. Same link will be used. So please do join, and that is going to be the last session. So we'll touch upon hierarchical clustering and some topics in the last week, including decision trees, the classification trees and the regression trees, and then we'll do a brief recap of what we have done so far. So tomorrow's session is going to be the last session, so please try to join. Like those of you who are having any queries, please join and ask whatever you want to. Okay, so let us go on to the first question. Euclidean and Manhattan distances between the objects 1, 2, 3 and 2, 1, 0 are. So if we try to solve this manually, let me just go to iPad, and then we'll see how to do it in Python. So the 2 points were 1, 2, 3 and 2, 1, 0. By the way, I think as far as I know, like in the last offering of this course, students were given certain link of calculator. So I think you are allowed to use some online calculator which they will be providing. So please confirm once. I'm not very sure about it, but last time they did provide some calculator like for calculation purposes. So yeah, please check that out once. Okay, great. Thanks Ritu for confirming. Yeah. So yeah, please get a hold of it. Like it was a pretty messy calculator when you use it for the first time. So you can't actually type on that calculator using keyboard. So you'll have to use uh, the numbers over there. Like you'll have to click on the numbers and then insert the numbers over there in the calculator. So please get hold of that calculator before appearing for the examination. Okay. So we have 2 points. Let's say this is x-axis, y-axis and z-axis. So this point is 1 on x-axis, 2 on y-axis, so it will be here, and 3 distances towards z-axis, so it will be somewhere over here. So this is the point in 3-dimensional space 1, 2, 3, and we have another point 2, 1 and 0. So it is lying on the xy plane. So this is our first point and this is our second point. Now the question is to find out this distance. Sorry, this is the Euclidean distance, and the Manhattan distance will be like, if you see in the 2D space, if you project this point on the 2D space, the red dot, let me just draw only xy. So we have this 2, 1 and 1, 2. So the Manhattan distance will be either you go this way or this way in the 2D space. Now we have one extra 3D space, like extra dimension over here. So just substituting it in the formula, like as we saw earlier, it will be 1 minus 2 plus 2 minus 1 plus 3 minus 0, which will be 1 plus 1 plus 3, 5. Okay. And what about the Euclidean distance? It will be 1 minus 2 square plus 2 minus 1 square plus 3 minus 0 square raised to 1 by 2. So it will be 1 plus 1 plus 3 square, 9. So under root of 11. So it will be around 3 point something. I am not using any calculator. So in the examination also, like if you are coming across such question, so you can have an approximation over here and then look at the options given to you. So this is the manual way of doing it. We will see it in Python as well, this particular example using Python libraries. So let us go back over here. Yeah. So Manhattan distance was found to be 5. So this is a trick, like for those of you who would have given JEE examination and other such examinations, so you can when solving certain question, like numerical question, you can rule out certain things. So we found that the Manhattan distance was the easiest to compute. So one of the options will be like either B or D. So the only thing that you have to confirm, what is the value of under root of 11. So once you get that, you will get a better estimate and then you can confirm the answer. Okay, so in this case the correct answer is 3.32. I think you will be allowed to use the online calculator. I'm not very sure like for all the questions it will be available, but yeah, if they are giving you the link, I think it will be available for all the questions, so you can just make use of that as well. Okay, so this was about Euclidean distance and Manhattan distance between 2 points. Okay, let me go back now, go to the Python notebook, and here we will see like the library that is used that can be used to compute distances. So we have used this SciPy library quite extensively in this course, even for statistical testing, like hypothesis testing. In this case, we are using this SciPy library for distance computation. So from scipy.spatial, we are importing this distance, and this distance has multiple distances, like including Euclidean and Minkowski. There are different types of distances available, so you can go to the documentation of this particular library. So let us just see that quickly. Sorry. So you can see a lot of things over here: Euclidean distance, cosine similarity, correlation, Mahalanobis distance, Minkowski distance, and so on. So there are a number of distance metrics and similarity metrics over here. So you can explore it further, but whatever is needed for you, like if you come across some certain problem where you will have to find out certain distance between 2 points, you can definitely refer to the manual of this particular library for the types of arguments that are passed into the function. Okay, so coming back over here. So in this case, we are mostly interested in Euclidean distance, Manhattan distance, and the generalization of that is Minkowski distance. So let's say we have these 2 points. So these were the same. These are the same points that we had in the question 1, 2, 3, and 2, 1, 0. So I have represented these points as list and passing these lists to this particular function distance.Euclidean. So let me just run this. So internally it tries to compute 1 minus 2 square plus 2 minus 1 square plus 3 minus 0 square to the power 1 by 2. Okay, so that's what is happening over here. Now how do we do it for Manhattan and in general? So there is a function for Minkowski distance, and we saw that it is a generalization of like Manhattan and as well as Euclidean. So you will have to have one extra parameter over here, that is p. So when p equal to 1, the distance measure will be, the metric will be Manhattan. When p equal to 2, it will be Euclidean, and so on. So let us run this. I am having this a and b only over here as input. Let us see what values we get. So if we can see that Manhattan distance was found to be 5, we solved it manually as well, and then Euclidean distance is 3.316, which is approximately 3.32, and then this is for p equal to 3, and so on. Now you might be wondering, like, why are we looking into all these distances and all? So that leads us to the next topic, that is similarity and dissimilarity. So I won't go into the details of all the cases that professor has discussed in the class, but we'll touch upon some key concepts. Okay, so why do we need to compute similarities and dissimilarities between the set of points? So that is the question. Like, can anyone like answer? Why do we do that? That will be the motivation for the next topic that we are going to see. So anyone, why do we need to compute this similarities and dissimilarities between the points? Okay, let us see that. Yes, that's correct. To divide into clusters. So that's the motivation for doing clustering. So you need to have a certain distance metric between the points to be computed between the points, so that you can cluster them. Now there are different types of clustering. We'll see that shortly. But sorry. So the main thing for any clustering algorithm is to compute certain distance or measure of similarity or dissimilarity between the pair of points, or like the given points. Okay, let me show it to you on iPad. So whatever let me just show it on 2D space. So let us see, we have this 2D space. Now let's say this is the mean of these data points, and you can see that the distances of this particular data points with respect to the mean over here is short, like less compared to smaller compared to the distances with respect to the data points in the other cluster. Okay, and this is the motivation behind computing distances. So using these distances, like distance between every single point, you can try to find out which points are getting clustered together. Okay, and this was the case of interval data. Like, you had the numbers over here, like x was having certain value 1 comma 2 or so on. Okay, so you could find out distances between these 2 points, any 2 points in this space, in this Euclidean space or Cartesian space, whatever you call it. So but the problem with other data types is, like, in the very first class we, or the second class, we saw different types of data. Can anyone recall, like, what were these different types? We had nominal, ordinal, interval, and ratio type data, right? So nominal data was having all these categorical data sets, data, male, female, and so on. and then ordinal was having categorical with certain ranks associated with them. Then interval was having certain values, like this is an example of interval data, like whatever we saw in the Euclidean space. They like you can find out certain interval between them, like you can do operations like subtraction, addition on top of interval data. Then ratio data was like in which the ratio had certain meaning associated with it, and it had a true 0 point. Okay, so we discussed that in the very big first session or second session. So what is the use of discussing it now? Because in a certain scenario you will be needed to find out the distance between different types of data. For example, I have been given data of let's say students. I have the, let's say, student 1, 2, 3, and then I have one data that is height, like one variable that is height, which is a continuous variable. Then weight, which is again a continuous variable. Then marks scored, which can be from 0 to 100, which is again this is a discrete variable. Then what else? Like gender, it can be male, female, and what else? Like so on. Okay, so you will be having certain values associated with each of these variables for each of the students, right? It makes sense to compare heights of two students, weights of students, and marks of students. But now coming to the categorical variables like gender, where you have male and female, in that case how do you find the distance? So you cannot do male minus male or something like that. Okay, so you will have to have certain values associated with this categorical variable, and that's what we do over here. So you can assign male as 1 or 0, and similarly female will be 0 or 1. So once you have this, you can define certain metric to find out the similarity between the two groups. This was for binary numbers, but there can be certain cases where you have multiple values associated with a category, a variable. For example, let's say grades. So grade can be A, B, C, D, and so on. So now how do we do that? This is an example of ordinal data. So let's say grade A is assigned the rank 1, the rank 2, rank 3, rank 4, and so on. Now once we assign certain numerical value to it, we can define some measure, distance measure between this particular grades of students. Now to do it on individual level is easy. Like you can find out, like if two students are having same height, you can see it from the height data, similarly from the weight, and so on. So students having same height will be clustered together, and then students having same weight will be clustered together, and students having same marks will be clustered together, and so on. But if you want to cluster them based on all these attributes, so in that case you will have to have appropriate measures for each of these categories. Like height was interval data, so you could do Euclidean distance or any sort of like just like absolute difference between the heights, so that can be done over here. Gender, you will have to define certain metric over here. I'm just giving you an intuition, like we won't be going into the details. Maybe I'll just go to the slides and then we'll just scroll over the slides and see like what all topics professor has covered, and you can go back and look into them into details in details. Okay, so once you have this, so you will be having certain vector for each of the student called as feature vector in machine learning lingo. So each feature vector is a point in the n dimensional space provided it is having n features, and one feature can be height, like one direction can be representing height, other direction can be representing weight, then the gender, which can have two values 0 1, height can be continuous, weight is also continuous, height is also continuous. So you will be having certain points in this space. Okay. So to compare height you can subtract, to compare weight you can subtract, to compare gender you can see the similarity metric for the gender. Again you can have another dimension which is having grades and so on. So the students having similar height, similar weight, similar same gender and similar grades or same grades will be clustered together in the space and so on. You can do clustering based on individual entities or variables, say height, weight, gender, and you can in the other way around you can just use all these variables, considering them all together to cluster different students. Okay, so this was the motivation behind all these similarity measures and dissimilarity measures, whatever was covered in the course. Let us go back to the slides and see what all measures were covered, and then we'll come back to clustering, and then we'll solve some questions, like I have some MCQs, so we'll look into the MCQs towards the end. Sorry. Okay, so in the very first slide for this week, professor talked about handling missing data. So it may happen in the real world scenario that you have been given these data for students, like whatever we discussed, like the height, weight, marks, gender and so on. But it may happen that for certain student you don't have the value for height or weight, that was not measured, the student might be absent, so you don't have that data with you. So how do you cluster that? So in that case, like there are certain techniques in which you can by using which you can find out the missing value, or you can predict the missing value. Not like you won't be getting the exact value of it. For example, let me show it to you on iPad. This is one technique that can be used, but there are several techniques available. So let's say you have been given like height, weight, gender, marks and grades. So you have students, 3 students, you have certain height, weight, associated with each of them. Or let's say like this particular entry is missing over here, and not just 3, there are actually many students, let's say some n students are there. So what do? One technique is like this is not the universal thing that can be done to find out the missing values, but one thing is you don't consider this particular variable. First of all, use these variables to cluster the students, like you cluster them based on this particular variables, and once you have the cluster you find out like which student are closer to this S2, and once you find a set of students which are closer to S2 in a given cluster, you can take an average of their weights and assign that average to this particular student S2. And now once you have this average, you can use all the 5, means you have this missing data available with you now, so you can use all these variables now to cluster them based on weights as well, like taking weight into consideration. Okay, so that was a simple technique that can be used to perform like to find out the missing data, but there are a number of techniques definitely, so please do check that out. Okay, I hope this part is clear to everyone. Like if it is not, please let me know like how do we do that? Like finding the missing data or estimating the missing data. It's not like finding it out, but it's estimating based on the nearest data points in the space. Okay, I hope it is clear to everyone. Yes, no? Okay, thanks. So this was all about handling missing data. Then professor moved on to dissimilarities. So these dissimilarities were like, again, as we discussed, like can be depending on the type of data, whether you have ordinal data, category means like interval data or ratio data. You can define certain dissimilarity or similarity metric and then compute the distances. So dissimilarities are nothing but distances over here that are computed. It is also called as like, so if you have say n data points, so distance of every data point with respect to other data point, let me just show it to you. Okay, there is a let's say you have these features in general. I have f1, f2, f3. These are the feature vectors. So the metrics that you find based on the distances of each point with respect to the other point. So what is f1 distance between f1 and f1? It will be 0. So all the data point, all the values on the diagonal will always be 0, because distance between the same points in any space is 0. Okay, and then you will be computing distances of each point with respect to the other point. So distance between f1 and f2 and f2 and f1 will always be same. Like you have 2 points in this space, so distance between these two, like let's say this is f1 and this is f2. So distance between f1 and f2 is same as distance between f2 and f1. So this particular matrix, which is also called as distance matrix or pairwise distance matrix or similarity matrix, there are multiple names depending on the kind of metric that you are using to compute this particular matrix. So it can be so the distance can be Euclidean distance or correlation based on Pearson correlation coefficient or any other metric that is available depending on the type of data you have at hand in hand. Okay, so once you have this data and this particular matrix is symmetric matrix, so in many of the cases or in literature you might be seeing that people only represent part of it or the lower triangular part of it. Why? Because the distance matrix is symmetric in nature. So whatever value you are computing over here will be the same as the one which is symmetric to it. Okay, so and in many of the cases you might be finding that these zeros are excluded, like in the slides of Professor Ramesh as well, you might be seeing like all these variables are mentioned, and then on the y-axis or the rows only other variables are mentioned, because the distance between f1 and f1 will be the same and so on. So the zeros are excluded in that. So this particular diagonal elements are excluded because we know that the distance between every 2 points, like a single point and with itself will always be 0. Okay, so now once we have this distance matrix, what can we do? We can use it for cluster analysis. and we'll see it later, different types of clustering. So k-means, k-medians, k-medoid, and hierarchical clustering. So what are some applications, real world applications of this particular thing, the distance matrix that you compute? So one thing is to we'll see it in hierarchical clustering once, but in the case of biology, this particular distance matrix are used to compute or to find out phylogenetic trees, and that is one of the major part of my research. So how do we do that? Like I'm just giving you an example. We have DNA sequences of multiple species. Let's say we have unknown species, like you have some hundreds of animals or species with you, and you have their DNA sequences. Now you find out some measure, some feature representation for every DNA sequence, and then you compute a distance matrix, which is also called as pairwise distance matrix. So this distance can be Euclidean distance between two vectors. This, by the way, these features are nothing but vectors in some space. Okay, so let's say 1 2 3 and 3 2 1. Either you can compute Euclidean distance between these 2 points, or you can find out the correlation coefficient, also known as Pearson correlation coefficient, PCC. So PCC, by the way, gives you similarity. If the two vectors are in the same direction, let's say, so their Pearson correlation coefficient will be almost close to 1, and if they are in totally opposite direction, it will be -1. Okay, so Pearson correlation coefficient can range from -1 to 1. Sorry. So this will give you the similarity. And how do you compute dissimilarity then? So if you are using Pearson correlation coefficient as the measure, you can use 1 minus PCC by 2 as the distance metric. So when the two vectors are same, exactly the same, so the PCC will be 1. In that case, 1 minus 1 by 2, so the distance will be 0. And when they are totally in the opposite direction, let's say these two vectors, so it will be 1 minus -1 by 2, which will be 1. Why this particular division was done over here by 2? To restrict the values between 0 and 1. Okay, so you will be seeing many such examples in the slides of Professor Ramesh, wherein he has discussed different distance metrics for different types of data. So the motivation in every case was to like convert the distance measure between, like, or to find the distance between 0 and 1. Like you might be having different values, like for certain type of data, like for example heights. So heights are, like, if you compute the pairwise distance matrix of heights of say n students, 1 2 3 4, so there might be drastic changes in certain cases, like the difference in the heights can be very different for a given pair of student than the other one. Now to have these values between certain interval, the values were normalized, and one of the normalization technique that is commonly used in the literature is min max normalization, wherein you have the data points, like, as this is symmetric, we will be looking into the lower triangular part of it, and let's say you have these values A, B, C, D. So normalization, how do we do that? Like to convert these values between 0 and 1, so we take A minus mean of all these values A, B, C, D and so on, and max of all these values minus mean of all these values. So this is known as mean max normalization. So what it does, this denominator is showing you the maximum range that you have in the data, like the difference between the maximum value and the minimum value, and then you are trying to subtract the minimum value from each of the data point and normalizing it with the length or the range. So this will give you value between the range 0 to 1. Okay, so this is known as min max normalization. There are other sorts of normalization, and one of the normalization that we saw in earlier classes was this z-score method, wherein you try to convert every data point into so for example, you have data points, you subtract the mean and divide by the standard deviation. So this is known as z-score. So this also converts data points from data points to a space wherein they will be having means mu and standard deviation sigma. So there are multiple ways to normalize data, and mean max normalization is what was discussed in the lectures. So yeah, once you have this distance matrix computed, you can do some sort of clustering, and in this case it is actually there are multiple algorithms that are used in bioinformatics to construct these trees. So you have the task was you had n different species, you get a feature representation for each species using their DNA sequences or any of the other measure, like let's say their color, height and so on, and then you find the pairwise distance matrix. Now the species that are close, using this pairwise distance matrix, you can construct one structure or data structure called tree, or it is also called as dendrogram, which shows you which species are closer to each other and which species are farther. Okay, we'll see this in detail in the clustering part of it. So this was just to give you motivation behind why do we need this distance measures, like why do we need to compute this pairwise distance matrix. So the main motivation is to do clustering. Okay, so let me go back to the slides quickly, and then we'll move on to Python. So whatever we saw was like quantitative measure or objective way of doing finding distances, but distances can also be found using subjective analysis. For example, this was the example given in the lecture, wherein certain students were asked to rate or subjectively say what is the distance between the different fields. Like for example, like computer science and mathematics are very close, so I might give them distance 1 or so on. So these distances were a survey was done, and the distances were found subjectively from many students, and then they were averaged out, like distance between astronomy and like all these fields. And whatever values you are seeing over here, these are average values, and how are they computed? They are computed using a survey done from students. Okay, so either you can compute it quantitatively or you can compute it subjectively using certain surveys. Then let me check if I have missed anything. Yeah, so this is what I was talking about, the Pearson correlation coefficient. Once you have this Pearson correlation coefficient, you can find out the distance between the 2 points using 1 minus PCC by 2 and PCC will the range of PCC is from -1 to 1. And these are the properties of distances, as we saw. The means similarities. So similarities can lie between 0 and 1. 1 means highly similar, 0 means not at all similar. And then the similarity between the point and itself will always be 1, and similarity or distance between 2 points ij will be same as similarity or distance between j and I. Okay, so these are some points. I won't go into the details of everything. And in the case of binary variables, like we saw gender, for example, it can have two values, 1 or 0, and then you find out like between a pair of students, how many such variables are having 1 and 1, 1 and 0, 0 and 1, and 0 and 0, and so on. So based on that, you can compute certain similarity measures. So these are all the similarity measures that are defined. uh, I would urge everyone to go through them and get a hold of it. It's not important to discuss everything in detail, but the main thing I wanted to discuss was the motivation behind the computation of distance metrics, and depending on the type of data you have, you will be computing the distance accordingly. Okay, so I mostly won't go into the details of all these things, and would urge everyone to go through it once, and please let me know if you have any queries. For those of you who joined just now, I'll be taking one more session tomorrow from 6 to 8, and that is going to be the last session for this course. So if you have any queries, please feel free to ask. I'll try my best to answer them, and we'll try to cover the week 12 topics tomorrow and do a brief recap of what we have done so far. So please try to join tomorrow from 6 to 8 using the same link. Okay. So is there any particular topic that you want me to discuss in this distance measures? So if there is not, then I'll skip this for the time being. Maybe we'll discuss it tomorrow. You can see over here, like for categorical data, you have certain measure for ordinal and interval. This is the one that we saw, like the mean max normalization. In this case also mean max normalization was done. So for example, like we saw the example of grades, wherein we had like grades A, B, C, D, E, F, and each grade was assigned certain rank. So minimum rank that can be assigned to the grades was 1, and maximum rank depends on the number of grades you have. So this is also in this case also you are doing mean max normalization. It's just that the minimum value is directly given over here as 1.
Sash,
Yes.
your slides are not visible.
Oh, my bad. My bad. My bad. Oh, all the time I was, I think, just okay. It got recorded. By the way, I'm not very sure if it was recorded or not, but I mean, I'm not sure if it was visible or.
Anyways, it was a easy part basically, so it was understandable by what you were explaining.
I see.
So
I see. Okay.
yeah.
Okay. Thank you for that. So okay, I was whatever what I was trying to say is like there are different distance measures that are explained by Professor Major Ramesh for different types of data, and we saw certain examples also, and uh, we need not go into the details of this, but what I was trying to explain over here is this is the mean max normalization that I was talking about, wherein we were trying to convert the distances in the range 0 to 1, and for the ordinary variable over here you can see that 1 is used over here. So I was giving an example of grades. So let's say you have like 4 grades A, B, C, D. So let's say A is having the highest rank, uh, let's say 4, then 3, 2, 1. So the minimum rank is 1. So in this case also you are actually trying to do mean max normalization and find out distance between like once you have this distance between the 2 points, you can compute the pairwise distance matrix and then do further analysis. And for categorical variable, actually this P represents the total number of variables that are there, and M represents the match. So out of total, when you subtract the match, you will be having the number of mismatches, and the number of mismatches upon total number will give you a distance matrix or dissimilarity matrix metric between the categorical variables. So yeah, there are multiple ways to find these out, but yeah, I'll urge you all to look into it it won't be possible for me to like discuss everything in detail in this session, but this was a precursor for the k-means clustering and the other clusterings that clustering algorithms that we are going to see now. So let me go, now quickly move to k-means clustering algorithm, and then we'll see a Python example for k-means, k-median and k-medoid, and we'll kind of briefly touch upon hierarchical clustering, and we'll look into the details in the tomorrow session. Again, I'm repeating for those of you who joined just now, I'm going to have an last session, extra session tomorrow from 6 to 8. So please try to join and get your queries clarified. I'll try to do a recap of whatever we have covered so far in the course, and we'll try to cover up certain point like concepts that are left, like the week 12 topics, which include classification trees and regression trees. Okay, so let me quickly go to k-means clustering algorithm. Sorry. So the basis of k-means clustering is the distance matrix, or the distance that you are defining between every pair of point. So in general, Euclidean distance is used, but it depends on the type of data you have in hand. So let's say we have these data points. Here I am giving you an example wherein you can visually see two different clusters, but it may not be the case in the real world datasets. You may have datasets like this, wherein the clusters are not so well segregated. So we'll discuss this in Python notebook. Like I have an example over there wherein you don't have a clear separation between the clusters, but yet k-means clustering algorithm can work. Okay, so the first step is to decide the number of clusters you have. Here visually we can see there are two clusters, but the first step is to decide the value of k, and let us set it to 2 in this case. Now second step is to select the means out of these data points. So let's say I select this as one mean and this as another mean. This is initialization. So first is like deciding the value of k, how many cluster you want. If it is 2, it can be these 2 clusters. If it is 4, it can be this, and so on. It depends. We'll discuss it how it varies. So you have this initialization now. The second step is to compute distance of every point with respect to these means. So you have initialized two means. These are the initial means, let's say mu1 and mu2. Now you compute the distance of this point with respect to this mean and this point with respect to this mean, and you will do this for all the data points. Now whichever mean is closer to that data point, you will assign that data point to that mean. What do I mean by assignment? Let's say let us color this as yellow and this as blue. So all these data points over here are having a shorter distance compared to with respect to this mean compared to the other one. So all this will be assigned this blue label. Okay, and similarly all these data points will be assigned yellow label, because the distance of all these data points is shorter compared to is shorter with respect to this particular distance with respect to this particular mean, yellow mean is shorter for these data points compared to the other mean. Okay. So once you have this assignment done, now you recompute the mean. And how do you do that? You have these data points, you take an average of all the data points and you get a re-estimated mean. Let's say the mean of this data point is lying over here, somewhere over here. And similarly for these data points, it might be lying over here. Okay. And you repeat the same process. Like once you have this re-estimated means, you compute the distance of every data point with respect to this particular mean and with respect to this mean, and do the assignment again. Like so these data points will get this red label and all these data points might be getting the green label. Now you have the red labels and green labels, you compute the mean of those and so on. You keep continuing this process till the point there are different criteria on which you can stop the k-means clustering algorithm. The first criterion is when the means don't change. What are we doing? We have random set of points. We take 2 points as mean, initial means. We compute the distance of every point with respect to this particular mean, these means, and then do the assignment. Once you have the assignment, you re-estimate the mean and keep on repeating the same process again and again till the point the re-estimated mean does not change much. Like let's say in this iteration I have this mean, and in the next iteration if the mean does not change much or if it changes slightly, very slightly, so in that case you will have certain threshold to stop the k-means clustering algorithm. That is one way. Another way is to define the max number of iterations. Let's say you want to perform this algorithm only for 100 iterations. So it depends on the kind of data you have. The k-means algorithm, if you just go by this thresholding method, it might take longer to converge or to come to the point wherein your means are not getting changed a lot. So in that case you will have to have certain cap on the number of iterations. Let's say I want to do this process only 100 times, max to max. It may converge within 100 or beyond 100. So max number of iterations that you are going to have for k-means clustering is 100. So that is one way. Okay. So sorry. So this was about k-means, but what problem do you see in this case? Is there any problem with this algorithm? Let's say let's say insert an example. I select this 2 as the initial means. Okay. So and in other run of k-means, I select this 2 as the initial means. So the chances are the way they are converging, like the end result, that the number of clusters that the clusters that you are getting, the number of clusters is fixed. The clusters that you are getting may not always be the same. It depends on the kind of initialization that you are doing. So it may also happen that the random initialization, the random number or randomly selected numbers might be in the same cluster. Okay. So the way you are initializing, that also matters, and for that we'll see in the Python example like how that we can control this initialization every time to have certain reproducibility in the results. Okay. So k-means clustering algorithm is sensitive to the initialization, and also there is one more problem in this. Can anyone identify? Let's say I have this data point over here. So these are the data points, and this is one data point over here. So what is the problem of this in this case? What problem can occur?
The centroids can be skewed.
Mm, uh, Not really, means like I'm not sure what you mean by that, but
The outlier will not be detected properly. It will belong to some.
yes, somebody has correctly answered that. It alone is a cluster. So for example, like if you select this as one initial mean and this as another mean, so now if you compute the distance of, like let's say this is an outlier which is very far away, and if you compute the distance of this data points with respect to this mean, it will always be shorter compared to this outlier. So this outlier won't get any assignment, any data assigned to it, and it will remain as a separate cluster altogether, and all these data points will belong to one cluster. So again, this is one drawback of K-means clustering algorithm. It is very sensitive to outliers. So if you have an outlier and if you select that outlier as a mean, initial mean, it is going to affect your algorithm. So all your data points will belong to one cluster, and then this outlier will become one independent cluster. So is it clear to everyone?
Yes, clear.
Yeah. So how do we resolve this issue? Like if we have outliers in our data, what instead of mean, what is the measure that, or measure of this like central tendency that can be used to avoid this issue? Like mean is very sensitive to outlier. So if we have these data points, let's say in one dimensional space, so their mean will be lying over somewhere over here, and if you have an outlier, so if you compute the mean of all these 5 data points, it will be somewhere over here. So the mean is the measure of central tendency, which is very sensitive to the outliers. So to avoid that, like what is the measure of central tendency that is used, which is not very sensitive to the, which is not sensitive to the outliers? Anyone? Yeah, somebody rightly answered. It's median. So instead of means, you can use median as the central tendency. So once you have this, so let's say you in k median so instead of k means clustering, you do k median clustering. So what the steps are similar. You select the initial medians, then find out the distance uh, of same Euclidean distance of every point with respect to the selected means, sorry, medians, and then do the assignment. So all these data points will be getting blue color assignment, and then let's say this is red. So now you will have to arrange these data points in ascending order in order to find out the median, and then you will compute the median of that particular data points. I'm just giving you an hypothetical example like how it is done. Let's say we are doing this clustering in 1D space. So you have this data point, you find out the distance of every point with respect to this median and this median, initial median, and then you take the ones, let's say these are all these data points are assigned blue and all these data points are assigned green. So you re-estimate the median from the uh, given assignment to the data points and repeat the process. So unlike mean, which is very sensitive to the outlier, in this case there are chances that the algorithm will converge uh, to a pretty distinct clusters. Okay, and then this was one example, but what is the thing that you can see in the case of mean and median? So let's say I have two data points on one line, which is 1 and 2. So what is the mean of these 2 points? It's 1.5, right? And is 1.5 a part of my data? No. So in k-means clustering or k-median clustering, uh, your the median or the means, the cluster means or the cluster medians that you might be getting may not always be the part of the data. For example, I am having this points over here. Let me just take 2D space. So you can see that these are the two cluster and their mean will be lying somewhere over here. In this case also the mean will be lying somewhere over here, but this mean is not the part of the actual data points that you had. So in this case, like in such cases wherein you want your data points to be the means, cluster means, you use this algorithm called k-medoid algorithm. So let me give you an example. Like let's say you have a city and you have certain houses in the city. Now you want to have like you want to put in mobile towers or the connection towers in the city, and you want to have minimum number of towers. Okay, so the best way, and you have like fixed number of places where you can have your towers. Like you can have your towers on top of each on these houses only, not anywhere else. So in that case you are restricted to have the data points as the means or the median, means the cluster centers. So you'll have to select or you'll have to do clustering such that the central tendency that you will be getting will be a part of your data. Okay, so in the k-medoid algorithm, this is ensured that the cluster centers that you will be getting will be one of the data points in your data. So it won't be any like random data point in the space, it will be one of the data points. So that is the main thing in k-medoid clustering. So we saw 3 types of clustering over here: k-means, which was having its own pros and cons. Then to address one issue of k-means, that is sensitivity to the outliers, we went on to k-median algorithm, which is not which is not so popular actually. The k-means is very popularly used in many machine learning applications, and one of them is Gaussian mixture models. I'll kind of like introduce what exactly it is shortly. And we have this another application which is k-medoid algorithm, wherein we saw the application of mobile towers. You need to have your data points as the central tendencies or centers in the cluster. You cannot have it anywhere in the space. So in that case you will be using k-medoid algorithm. Okay, but in all these algorithms, one thing is the way the clustering is done. So every data point, let's say you have these data points, let me show it to you on 1D space, that will make it clearer. So when I form clusters, let's say I have these 2 clusters, every data point in this particular cluster, in this blue cluster will fully belong to the blue cluster. and every data point in this cluster will completely belong to that particular cluster. So it can be 0 or 1. It's like hard clustering. So the term that is used over here is hard clustering. So you do a hard assignment of the data point. So this data point belongs to this blue cluster with probability 1 and to red cluster with probability 0. Similarly, this data point belongs to this cluster with probability 1 and to this cluster with probability 0, and so on. And similarly over here, with respect to this it is probability 0, and with respect to this particular cluster it is probability 1. So this is the hard way of doing clustering. But what if you decide to have certain assignment in which every data point will belong to every cluster with certain probability, and that is the foundation for Gaussian mixture models, in which what you try to do, so you have these data points. First of all, you do the k-means clustering, get the clusters, and then you try to put in a Gaussian distribution. So let's say this is one Gaussian distribution, and this is another Gaussian distribution. Okay, so now what happens, this particular data point belongs to the blue color Gaussian as well as the red Gaussian. Like, though its probabilities or the probability density is pretty low, but still it has certain with certain probability it belongs to this particular cluster, and with certain probability it belongs to this blue color one. So this is the soft way of clustering. So this is known as soft clustering.
This can it be called fuzzy clustering?
Fuzzy clustering, yeah, kind of like it's a fuzzy way of doing. So, but I'm not sure if this term is used, but the
Okay.
hard
No, it's not used.
yeah,
This
yeah, means
Gaussian.
yeah, but
Yeah.
hard clustering and soft clustering are the technical terms used for naming this clustering methods. So Gaussian mixture modeling, it does soft clustering, whereas K-means clustering, it is a hard clustering term.
Hardware.
Yeah, and Gaussian mixture models have quite a lot of applications. Please look into that, and one of them is like classification of different uh, classes, like let's say species. So I can build a Gaussian mixture model for a given species, and then a Gaussian mixture model for another species, and given unknown data point I can find the likelihood of that data point with respect to the GMM or Gaussian mixture model of that species. Let's say I have species 1, I have Gaussian mixture model for that. I have species 2, I have a Gaussian mixture model for that. And given the unknown data point, I compute the likelihood with respect to this Gaussian mixture model and with respect to this Gaussian mixture model, and whichever is giving me the maximum likelihood, I assign that data point to that particular class. So this is one of the applications of Gaussian mixture models, and there are multiple such applications. We won't go into the details of it because it is not a part of the course, but this was just for your information. So let us go to Python notebook and we'll see.
Yeah, is there any Python code, any application Gaussian mixture model using Gaussian mixture model and Python
Yeah,
code for it? If
yeah,
you have, could you
there
please upload?
like I can redirect you to certain resources, like in sklearn there is this. So if you search Gaussian mixture model in Python, you will get this sklearn library. So in sklearn library you have certain functions which you can use to build Gaussian mixture models on the data points or the data set you have.
There will be examples. No?
Yeah, there will be examples, and you can look into the examples. Like there are other sources which provide codes as well. So if you see uh, GitHub, so you'll get multiple implementations of GMM, like every,
Yeah, right.
yeah,
Okay, thank you.
yeah. So you can see over here in the case of GMM, every data point is belonging. So if you see, there are no hard boundaries. So yeah, so these are all Gaussians seen from the top. So it is in the 2D
Not clearly
space.
separable cases, right?
Yeah, so yeah, and it is also like as k-means clustering algorithm is sensitive to the initialization. Gaussian mixture models are also sensitive to initialization, because the initialization in this Gaussian mixture modeling is done using k-means clustering. That is another issue, like it is known as incomplete data problem. We won't go into the details of it, but yeah. So it depends on the kind of clusters you get or the kind of Gaussians you get at the end. It depends on the kind of initialization you are doing. So yeah, that is one issue. Let us go now see sorry k-means clustering algorithm in Python. And here are some dissimilarity or distance metric computation that I have added over here, so you can play around with it. So in Python, scipy.spatial, you have this distance matrix. Similarly over here, as we use scipy.spatial, from scipy.spatial we use distance to compute distances, Euclidean distance and Minkowski distance. And in the same module scipy.spatial, we have this distance matrix which is used to compute pairwise distance matrix between the data points, given data points. So in this case we are having these 3 data points 1, 4, 2, 5, 3, 6. Let me quickly run this. Okay, so you have 3 data points and you are passing this data point. So df.vals, what it does over here, so it will give you the set of values in this data frame. So df.values and df.values, so what it will do, it will find the pairwise distance matrix, like it will find the distance of 1 with respect to 2, 3, and 2 with respect to 1, 2, 3, 3 with respect to 1, 2, 3, and so on. Let me just print this out over here. Okay, so 0, 1, 2 are the labels given to these data points. So this particular matrix shows the distance between every pair of data points. So you can see that along the diagonal it's 0, because distance of a point with respect to itself is 0, and then the matrix is symmetric in nature. Distance of 1, 0 is same as distance of 0, 1. Okay, so yeah, this is the function that is used for distance matrix computation. So you will have to remember such things. They may ask you in the examination, like which is the Python module which is used to compute distance matrix, so or which is used to compute Euclidean distance. So yeah, these are the basic things that you need to remember, because these were used in the course. Okay, here is another example in which you have more number of data points, and then uh, you can see the distance matrix computed using this distance matrix module over here. Since it was not able to display it, all these data points over here in single thing, it is actually shown on the next line, but it's actually a square matrix. Okay, so let us see this k-means clustering, and then we'll move on to questions, and then we'll stop for today. So for k-means we are using again this sklearn library. It's the same library which was used for the Gaussian mixture models and all. So it has many machine learning algorithms implemented in it, so you can use it for many things. We'll see it later. Not sure if for decision trees any codes are available, like in the provided by Professor Ramesh. I'll have to check that out once. Okay, So we are reading this data from clustering example.excel file, and you have these two variables, variable 1 and variable 2. In real world scenario, it can be anything like height and weight, some other values. Now the task is to plot this. So I won't go into the details of all this, but what we are having over here is a scatter plot of these data points. So 1 comma 1, 1 comma 1.5 comma 2, and so on. So these data points are there in this space. Now the task is to do k-means clustering, perform k-means clustering algorithm on top of it. So for that we are using this sklearn.cluster, in which we are using specifically the k-means module. So we have this k-means, we are passing the number of clusters to the k-means module, and we are initializing an object over here. Now what is an object? For that you need to know certain object oriented programming concepts. So I won't go into the details, but what you are trying to do over here is you are trying to create an instance of k-means with an number of clusters equal to 2, and then once you have this instance, you use that instance to apply k-means algorithm on the data using the fit function. So you are initializing this instance using this k-means module, and then using that you are fitting the data, or you are applying the k-means algorithm on top of this data, whatever data you have. So the data is in the data frame. So it internally does the k-means clustering, and let me print the labels over here. So you can see this first two variables 0 and 1 or over here are assigned label 0, and the other variables, other data points are assigned label 1, which means that the first two data points belong to the first cluster and the next data points belong to another cluster. Let us try changing the value of k over here. Also let me just print the centroids. So 1.25 and 1.5 and 3.9 and 5.1 are the centroids, and let us see also over here in the space. So you can see that these centroids are not actually the part of the data points. Let us try to run it for 3 number of cluster. Okay, so looks like only one data point was assigned over here for this cluster, so this code is not working fine. I'll have to resolve the bug, but yeah, you can see from here. So the first two data points, they were assigned to one cluster. Then the the third data point, this is 3, 5, 6 and 4. I'm not sure. Okay, this is the 4. So this 3, 5, 6, 7, these are assigned to one cluster, and this 4 is assigned to one cluster. And this is one of the problems that we saw for k-means clustering. If an outlier gets assigned as mean, so it will itself become a cluster. So in this case you can see that this data point is lying independent, like separately as a cluster, and the other data points are totally different. So this is one problem with k-means clustering. So the way you initialize the means, it significantly affects the end result or the kind of centroids that you are getting. It will be more clear from another example that I have. So let me just okay, we can try it out with 4 over here, and let us see the labels. So now you can see this first two data points are assigned 0 label, then these data points are assigned 1, and then there is only one data point belonging to cluster 3 and one data point belonging to cluster 2. So yeah, so the conclusion is like your initialization and the number of clusters affect your end result, like the kind of clusters you are getting, and it will be clearer in the other example that I have. So let me go to that. Okay, so you might be seeing some Greek and Latin over here. So this is lambda function. For those of you who do not know what lambda function and map does, let me briefly talk about it. So W3 schools is what I recommend to everyone. Like if you have any Python syntax related query, please do visit. This is a wonderful website for learning Python syntax. Definitely you will have to solve certain problems to get hold of the Python programming, but for any syntax related queries, you can come over here and learn the basics. Yeah, there are other tools available, like you can definitely go to forums, or you can either use GPT, but GPT is again like prone to errors. So yeah, for syntax related things you can come over here. So lambda function, so in general function in Python can be defined as, okay, let me def function name, the arguments that you want to pass in a, b, c, d, and then you will do certain operation, like let's say d equal to a plus b plus c, colon is semicolon is not used here. In the recent versions of Python, like they also use semicolon, means it is allowed, but we'll avoid it over here. It's mandatory in languages like C, C++, but not in Python. But one thing that is very important in Python is indentation. So you'll have to take care of indentation, because indentation signifies the block. Sorry. So this is the way you are defining a function. So you have a function name, you have arguments, and it is doing certain operation, and you are returning the value. Okay. So but one thing is, you are having certain name for that function. What if I don't want to define, like I don't want to define a function with any name, like I am exhausted with all the names I have. I'm just concerned about the functionality of the function and not about the name. So in that case, we use this lambda functions. These are also called as anonymous functions, because these functions don't have any name as such. It only represents the input and the output. So what it does in this case, lambda a plus 10. So you are giving a as input to this lambda and getting a plus 10 as output. So this lambda function is assigned to this variable x. So if I call this variable with this argument 5, it will act as a function, like you are giving 5 as input, so it will go to a and it will output 5 plus 10, that is 15. So that's the simple example of lambda function. And there is one more example I think given over here. Yeah, so this is with two arguments, lambda a b. It will do the operation of a into b and return it. So you are assigning this lambda to x. You can give any random name to this variable sorry, and then call x of 5, 6, and it will return you the value. That is the multiplication of the two values that you have given as input. So that is the advantage of lambda function. You can just define a lambda function and assign it to a variable and use that variable as a function. Okay. And then another concept over here that is used is map. So what map does? So let's say you have a function defined with you, and you want to apply that function to a set. or tuple or any list. So you can use this map function which applies a given function to a set of data. It can be a set, it can be a list, or any iterable. So in Python, iterable is an object on which you can iterate. So in this case, you can iterate over the elements of the tuple, right? This is a tuple in Python. So you can iterate over this elements of tuple, and what this map function is doing, it is applying this my function to each of these entities over here or entries in this tuple. So let us run this over here. So this my function is called an apple. Apple will go to my function and it will return the length of that particular string. So it is 5. Similarly, it will go over here, return the length and print it over here. So yeah, so the basic functionality in map is to map this function on each of the elements in the iterable. So that's what is happening over here. This is just to assign color to the data points. So a function was defined, lambda function. I won't go into more details of it. So you defined some function and then you are trying to assign certain color to the labels. So labels are 0 0 1 1 1 in this case. So this is a list of labels. So you are assigning certain color to each of the label depending on the value of the label. So that's what is happening over here. So the red color is getting assigned to all these data points over here, and the blue color is getting assigned to the data points over here. Okay. And colmap is a dictionary over here, which is like 1 means red and 2 means blue. Okay. So this was K-means clustering algorithm, and I have one more example over here. So what is happening over here? Again, I'm using this sklearn clusters K-means. I'm generating some random numbers, some 100 random points using this numpy.random.random, which creates 100 data points in 2-dimensional space. So whatever dimensional space you want to have, you can have it over here. So 100 data points in 2D space. You can have 3D space as well as ND space, depends on the kind of problem you have. And then one more thing you might be seeing over here is seed. So what this seed does, it restricts the way the random numbers are getting generated. So for a given seed, so as I said, like the K-means clustering algorithm is very sensitive to the initialization that you do. So initially you might select any random points as the initial means. So sorry. So the way they are initialized, the means are initialized, that will affect the clustering, the final clustering result. So to have reproducibility in the results, you set the random seed, and that seed will ensure that every time you run this code, same number of data points, same data points, exactly the same data points will be chosen as means, and the kind of analysis you will be doing will be can be reproduced. So let me run this once, and you can see that 100 data points were created. Then we had this seed. We are applying this K-means clustering algorithm in which we are passing the value of k. So k equal to 3 over here. Let me just make it 4. So you can see that 4 clusters are formed now. Let me increase it to 5. You can play around with this notebook later. You can see 5 clusters over here. Now let me just go back to 3 clusters and change the value of the seed. Let's say 40. So you can see that the clusters got changed a bit. let me copy this code, entire code, run this, and I'll run it with different seed value. So can you see the difference here in the clusters? The kind of data points that are getting generated, these are also different in this case. So if you see, this data points are getting generated using some random seed. Sorry. So let me try one thing. Let me put a random seed over here for data point generation, and this random state over here I'll change it, so that the number of the data points that are getting generated are exactly the same. Okay. So can you see these data points now are exactly the same that were generated by this particular np.random.random. But what we have changed over here is the random state for k-means, which is again a random seed for the k-means clustering algorithm. It is initialization. So the way the clusters were initialized earlier and in this case are a bit different. It may happen that the both things are getting converged to the same clusters, but in certain cases it will vary a lot depending on the initialization. So in this case it's almost the similar, like even with this particular initialization, let us try out some other random initialization, let's say 4. Yeah, so with certain in this particular example, it's not a very good example to show that the final result will change depending on the initialization, because the clusters are well separated in this case. But in certain cases it may happen that the depending on the initialization you do, the clusters also, the final clusters will also change. Okay. So this was one example, and I've added one code for k-median clustering, but please do check it properly. Like I have not seen any bugs so far. I have not come across any bugs so far in this code, but yeah, please do look into it. It's not a part of the course, like it is not taught in the course, k-median clustering algorithm, but it is just for your information, like you can just play around with it whenever you have time. So in the case of k-medians, the central tendencies that you are finding, the centers of each cluster, is the median of all these data points over here, unlike k-means clustering where the centers were the means. Okay, and then we have this k-medoid algorithm, in which you can see that the cluster centers are part of the data points, are like one of the data points. This particular center is this data point over here, this particular center is this data point, and so unlike k-means clustering and k-medoid clustering, k-median clustering, where the centers can also be some other data point which may not be a part of the given data points, in k-medoid you will be strictly having the data points as one of the data points as the cluster center. Sorry. So this was all about the coding part of it, and the two main things that you need to remember is the distance module and the distance matrix module over here, and then one thing that was used is the k-means sorry, sklearn cluster in that k-means module is there. So there might be a question on like which function is used to find or to perform k-means clustering on a given data. So you should be able to answer that. So let us quickly go to the MCQ questions, and I will stop here. sorry. Okay, decision tree is something which I have not covered now, but I'll quickly talk about it. Sorry. We'll see it in tomorrow's session. So, tree is a data structure. For those of you who have studied computer science in the undergrad level, so you might be knowing about it. So I'm just drawing a binary tree over here, which has, so this is known as root of the tree, and these are the nodes.
Not
Your
visible.
screen is not
Oh,
visible.
I see. My bad. Okay, let me explain it to you again. Yeah. So I was talking about the tree data structure, wherein you will have a root node, then you have the internal nodes. So this is a binary tree that I am drawing. It can be a k-array tree as well. So this particular node is known as the parent node of all these nodes, and the nodes which are at the end are called leaves, or this node is called as leaf node, and this is the root node. So it's like a tree upside down. So this is root, this is leaf, and these are the internal nodes in the tree. So what are decision trees used for? As in its name, it can be used to make decision. We'll see like classification regression, but in our case we'll see one simple example. Let's say you have two students, S1, S2, and you have different attributes associated with them: weight, height, gender, and so on. So the first question you ask, what is the gender of the person? If it is male, you go over here. If it is female, you go over here. Now, what is the weight? Is it lying in a certain range, let's say 20 to 40? So you do certain task over here. If it is 40 to 80, you do certain task, 80 to say 120 or so on. You perform certain things. So this can be used to make certain decision, like depending on the kind of attribute. So I have this data point, let's say student 1, alpha C. Again, this is one thing. Decision trees are built. These are also machine learning models, and and the way you choose these nodes, like here I am selecting gender as the root node, but it can be height or it can be weight depending on certain criterion. So we'll see that in tomorrow's session. So yeah, so in this case, let's say we have this decision tree already with us. So we are trying to find out or trying to make certain decision for a given student, looking at each of the attribute. So if the gender is male, you then check other attribute height. If height is in certain range, then you go on to the next level and you see the weight, and if weight is in the certain level, and so on. So that can be used to make certain decisions. So this so and so treatment can be given to this particular student with this gender, this height, and this weight. So one thing is we are making decision, but indirectly we are also trying to do something over here, that is we are trying to cluster the students. So students with male, all the males will be clustered separately, all the females will be clustered separately. Okay, Now if you want to do further level of clustering, so all the students with weight or height in weight in the range 20 to 40 will be clustered, all the students having weight 40 to 80 will be clustered together, and so on. So a decision tree can be used to make certain decisions, but in this case it can also be used for clustering at every level. So we'll come across hierarchical clustering shortly. So this is an example of hierarchical clustering, wherein you are dividing all the students into two groups, and then in each group you are further dividing into multiple categories, and so on. And this is an example of divisive clustering. So we saw K-means clustering on a broader level can be partitioning and can be hierarchical clustering. And in partitioning we saw K-means, median and madoid. And in hierarchical we have two types of clustering. One is divisive, and one is agglomerative. So what divisive clustering does, let's say you have a big cluster, like all the data points are there. You somehow try to segregate this data into two parts, and then in each part you try to segregate it into multiple parts, and so on. So at the end you will end up getting like whatever number of cluster you want. You first of all have the root, you divide it into two or more parts, and in each part you do further division. So this is known as divisive clustering. And if you have let's say all the data points, you combine let's say these two data points into one cluster, these three data points into one cluster, these two into one cluster, and these three into one cluster, and then you further combine these two clusters to form another cluster, and then altogether one particular cluster. So in this case you are going from top to bottom. So it is also called as top down approach, and here in this case you are going bottom to top, so it's known as bottom up approach. So this is divisive clustering, and this is agglomerative clustering, where you are trying to club, so everything is a separate cluster initially, and then you are trying to combine, merge them, and then merge further. In the case of divisive, everything is combined already, you are trying to divide them further and further at each level. So that's the basic concept behind hierarchical clustering, the two types of hierarchical clustering, one is divisive and one is agglomerative. Okay, so coming back to the question, so can decision trees be used to for performing clustering? So the answer is true. Oh, sorry, again I am not sharing, I think. Okay, let me share the tab. Next question, which of the following facts about hierarchical clustering is true? Okay, by the way, dendrogram is nothing but that tree structure that I made, so that is also called as dendrogram. Yeah, so the correct answer is D. Hierarchical clustering method comes under either agglomerative or divisive, that we saw just now. Hierarchical methods suffer from the fact that once a step, merge or split is done, it can never be undone. Yes, true. a tree structure called a dendrogram is commonly used to represent the process of hierarchical clustering. Next is select some facts about k-means clustering. Yeah, some of these questions you might have come across in your assignments, so I'll just quickly go over them. So yes, it comes under partitioning. The number of clusters are predefined. We'll have to set the number of clusters initially. And the cluster similarity is measured in regard to the mean value of the objects in the cluster. For two runs of k-means clustering, is it expected to get same clustering result? Yes or no? Yeah, so as we discussed, it depends on the kind of initialization you are having. So for example, the outlier case, so always consider that example. So if your initial mean is the outlier, then in that case your outlier will remain as a separate cluster and all the other data points will get assigned to another cluster, like if you have two number of clusters. So and if you don't select that outlier as the initial data point, then you might be ending up getting like the different set of clusters. So yeah, it depends. So the answer for two runs of k-means clustering, is it expected to get same clustering results? No. But
This question didn't specify if the parameters were going to be different.
yes, that's what I was coming to. So the question is not well formed actually. Like they should be specifying that the seeds are not fixed over here in this case. So if the seeds are fixed, then yes, uh, the results are going to be the same. But like implicitly it is given that in every run the seed might be different. So in that case, no is the correct option. Formula for dissimilarity computation between two objects for categorical variable is where p is the categorical variable and m denotes the number of matches. So we have not seen these things in detail, but yeah, p is the total number of variables and m is the number of matches. So how will you find out the dissimilarity between the two categorical variables I and j? It's intuitive question. Okay, I'll just go to the answer. So it's p minus m by p as we discussed earlier. So m denotes the number of matches. So p minus m will represent mismatches, and mismatches upon total number of categorical variable will give you the dissimilarity value between the categorical variables. So yeah, I'll skip that part. Which of the following is not a clustering technique? It's a straightforward answer, regression. Which of the following is true regarding clustering and clustering techniques? Okay, so both are true. Clustering is a task of dividing the data sets into certain number of clusters, right? The clusters are regions where the density of similar data points is high. Okay, and again I think this question was asked in the previous session as well, which is what is the minimum number of variables required to perform clustering? Yeah, so the correct answer is 1. You need at least one variable, like in 1D space or 2D space or 3D space. So at least 1D space should be there, like to have clustering. Which of the following algorithm is the most sensitive to outliers? Okay, yeah, k-means clustering is the one. Dash is used for calculating distance measures in clustering using Python. Yeah, again, it was a library related question. You might get some similar sort of a question in your examination. So yes, distance matrix is what we use. Select the correct option for a dataset with 7 objects and an interval scale variable f. We have the following measurement. F is given like this. This is the data point. These are the data points in the set f containing one outlying value. So which of these options is correct? Okay, what about others? Yeah. So the correct answer is standard deviation. Why? Because in standard deviation you are trying to find out the variance first, and in variance you have the squared terms. So first of all you will compute the mean. Mean itself will be affected by the outlier, and on top of it, like the standard deviation values will be like more penalized, like the with respect to the mean. So yeah, so the correct option over here is standard deviation is more affected by outlier. Which of the following can act as a possible termination condition in K-means clustering algorithm? Yeah, so we discussed it already. You can have a fixed number of iterations. Centroids do not change. That is one thing. Terminate when the residual sum of square fall below a threshold, which is actually equivalent to centroids not changing, because say you are finding out this squares Euclidean distance with respect to centroids. So this is actually the same thing stated in a different way. Assignment of observation to cluster does not change between iteration except the class with the bad local minima. Okay, so here also the same thing, centroids do not change. That is what is happening. Bad local minima is something so it might happen that a given data point in every iteration might get switched to different clusters. Like in one iteration a data point might belong to cluster 1, and in the next iteration it might belong to cluster 2. So if that switching or jumping of data points happen, so in that case you are not going to get a very your algorithm is not going to converge properly. So yeah, so in that case also it will be difficult to converge, but you'll have to have certain fixed number of iteration to stop the algorithm. Okay, so answer is 1 2 3 4. Which of the following clustering requires merging approach? Yeah, hierarchical clustering. Hierarchical clustering can either be agglomerative or divisive. Yeah, it's straightforward true. Yeah, so that's it for today. So we'll meet tomorrow from 6 to 8, same time, same meeting link. I'm not sure if it was announced by NPTEL. Sorry.
We just received a mail a while back.
Oh, is it? Like, did they
Yeah.
announce?
Yes, and it has a link also.
The same link, right?
Yes, yes, yes.
Okay, cool, great. So yeah, I'll be having the last session tomorrow. For those of you who are having queries, please let me know like what topics you want me to revise. I'll try to revise everything, like a brief recap of all the things that we have covered so far. And yeah, where can I see all the previous videos from this course? You mean the live sessions, Ritu?
Yeah.
Yeah, so these are all
Yeah.
available. Okay, so these are all available on my YouTube channel, NPTEL live sessions. I'll just share the link over here. Okay. Let me share the playlist.
Also, I had a request. Like the tomorrow's session, which you are going to conduct for revision,
Uh-huh.
can that be divided into two sessions, like tomorrow and day after, so we can
No,
gain
actually,
maximum of it?
no, actually, I'm restricted by tomorrow. Actually, I had to request for this extra session tomorrow. I won't be
Okay.
able to do it like later. So NPTEL has certain restrictions. So yeah, tomorrow's date is what I got.
Not later, maybe divided into two sessions for two
Uh,
2 hours, so we can gain maximum out of it.
yeah, unfortunately, I won't be able to do that because I'm assigned only 2 hours tomorrow, and yeah, there are other TAs who are definitely taking on other days till Tuesday, so you can definitely join those sessions as well.
Okay, thank you. I really like the way you've been teaching us. Really, thank you so much.
Thank you for the compliment. Thank you everyone for joining, and I hope you have learned something from today's session as well.
I just wanted to know, are the dates out for the exam?
Sorry.
The dates are out for the exam?
Yes, I think somebody mentioned in the very beginning exam will be on 27th of April.
Okay.
Yeah,
Thank
and yeah, I think it was announced on the SWAYAM portal. I'm not very sure about it, but yeah, please keep checking the SWAYAM portal. Like, uh, uh, you might also, if you have any question, you can just go to the Q&A section over here, and you'll be redirected to a Google group wherein you can see all the queries of other participants or enrolled students. And you can also ask your queries over there as well, like if you finding certain thing difficult to understand, so you can ask that question over there, and then one of the team members will try to answer to you.
Actually, this format is very tedious to find or search for something.
Yeah,
Yeah.
that is true, but yeah, but this is for those actually like who are not able to join these sessions, and then who have certain doubts relating to the assignment and all, so they, and anything relating to the course that can be put over here, and it's not like restricted to other means like the team members. If you know certain answer, you can go over there and reply to the person. Like if someone has asked any question over here, you can, and if you know the answer, you can go and reply to the person. So it's like helping each other. Yeah, so that's all about today's. Yeah, so please let me know if you have any query in any of the topics, and if you want me to specifically revise any particular topic, so please do let me know. I'll try to prepare some material for that. So are there any topics you want me to cover?
So regarding Z and T tests, can
Okay,
you just highlight about this?
I
Just
see.
revise
Yeah,
them.
okay, I'll revise all the topics. ANOVA, I see.
Yeah, on ANOVA also.
Okay, yeah, I'll cover all, I'll try to cover like these three topics: Z test, T test, and ANOVA. Fine, fine then. So okay, let us meet tomorrow from at 6 o'clock at the same link. So thank you everyone for joining. I'll end the session now.
Thank you, thank you.
Thank you.
Thank you. And tomorrow's session is going to be the last session. So yeah, please get all your queries ready. I may not be available after that. So thank you. I'll end the session.